Do not try this at home. We are trained professionals. What happens when a drive is subjected to higher voltage than it's rated for? Well, you may think that the drive is fried, but not so fast. A tiny component called an MOV may have just saved the day. Here's Katie, our MOV expert, with more.
An MOV, or metal oxide varistor, is a voltage-dependent, nonlinear device that provides excellent transient voltage suppression. It absorbs potentially destructive energy and dissipates it as heat, thus protecting vulnerable circuit components and preventing system damage. An MOV contains a ceramic mass of zinc oxide grains and a matrix of other metal oxides, such as small amounts of bismuth, cobalt, and manganese sandwiched between two metal plates, the electrodes. The boundary between each grain and its neighbor forms a diode junction, which allows current to flow in only one direction. The mass of randomly oriented grains is electrically equivalent to a network of back-to-back diode pairs, each pair in parallel with many other pairs. When a smaller moderate voltage is applied across the electrodes, only a tiny current flows, caused by reverse leakage through the diode junctions. When a large voltage is applied, the diode junction breaks down due to a combination of thermionic emission and electron tunneling, and a large current flows. The result of this behavior is highly nonlinear current voltage characteristic, in which the MOV has a high resistance at low voltages and a low resistance at high voltages.
To demonstrate how MOVs work, we're going to simulate a power surge, where 400 volts goes through our 200-volt drive, and then open it up to see what happened. Looking inside the drive, you can see that one of the input MOVs is burnt, but the rest of the drive doesn't seem to be damaged thanks to the MOV. We will check the rest of the drive to make sure everything's working correctly and then reassemble the drive.
While a MOV is designed to conduct significant power for very short durations, it typically does not have the capacity to conduct sustained energy. Application of sustained overvoltage to a MOV can cause high dissipation, potentially resulting in the MOV device catching fire. While metal oxide varistors are widely used in many AC power electronic circuits to protect against transient overvoltages, there are also other types of solid-state voltage suppression devices such as diodes, Zener diodes, and suppressors, which all can be used in some AC or DC voltage suppression applications along with varistors. For more information, please visit us at galco.com.